Alright, in this video I'm gonna try to show you how you can quickly get these coordinates of points quickly, trying to find some mnemonic way to remember them. Actually, these are not mnemonic ways, just remember, there's memory of course involved, okay? So this is the unit circle. How do you know it's a unit circle? Well, look at the coordinate of these points, okay? This is 1, this is the x-axis right here, alright? This is a y-axis right there. So these points are very simple, okay? And you know that because we're working on the unit circle, the x coordinate is going to be the cosine of the angle, and the y coordinate is going to be the sine of the angle, and the angle right here would be this one, okay? So the angle, I'm going to use radian, but let me tell you, in degree that's 30, in radian it's pi over 6, okay? So of course this what I'm going to show you, assume that you know how to place angle and you know how to draw the circle. This is something we've been working it for a while, okay? So let's go. First of all, I will look at 3 families of angles. Here you're gonna have the pi over 6s, okay, right here. Here you're gonna have the pi over 3s, okay, 1, 2, 3, and 4. And then right here you have your pi over 4, okay, which is the easiest. Pi over 4, it's the easiest. Okay, I'm not going to look again at the quadrantal angle because the coordinates are very simple. These are the coordinates of the points, sine and cosine. You can quickly find it, okay? So let's go. If you remember how to construct the unit circle, or rather the circle with all the points on it, all the angles, you draw a circle, and here's the x-axis and here's the y-axis. I'm going to start with the pi over 6 angles, and you remember you go to 1/2 right here, you go to 1/2 and you draw parallel lines. So let me draw just the horizontal line right here, okay? I'm gonna draw just the horizontal line right there, and in this circle right here, oh, this is actually not a bad circle at all. No, I don't want that. This, can I select this? Can I copy? Copy. I don't know if that's gonna work. And what am I gonna paste? No, forget it. All right. Here's another circle. Here we go. This line is a bit too high, I guess. Here we go. Again, I'm gonna cut in half, right? This, but this time I'm gonna draw the vertical line. Okay, if you draw the horizontal line, you are pretty close to the x-axis, right? The horizontal lines are closer to the x-axis right here. Do you see that? Well, if you draw the vertical line, you're gonna find yourself closer to the y-axis, right? What angles do you have when you draw the horizontal line? You have the smaller one. The smaller one is pi over 6. So this is pi over 6. This is 5 pi over 6, right? 6 pi over 6 is pi. This is 6 plus 1, 7 pi over 6. And this is 12 minus 1, 11 pi over 6. 12 pi over 6 is 2 pi, okay? And so what are the coordinates of the point? Well, that's pretty simple. And by coordinate, I mean the sine and the cosine, okay? It's pretty simple, right? You can, by construction, you see that this is, oops, undo that. You see this point right here, that's 1/2. And this one is negative 1/2. So my y coordinate is very simple. It's 1/2 right here, and it's negative 1/2 right there, okay? Negative 1/2. And by the y coordinate, I mean the sine, okay? So the sine of pi over 6 is 1/2. The sine of 7 pi over 6 is negative 1/2. What's the cosecant of 11 pi over 6? Cosecant is 1 over sine, so the cosecant of 11 pi over 6 is negative 2. We'll go over it after, okay? Don't worry about that right now. Okay, so what's the second coordinate? Well, this you need to know. If it ain't 1/2, it's root 3 over 2, okay? So you need to adjust the plus or minus right here. So right here, this one is going to be positive. And this one actually is also going to be positive, right? Same x coordinate, right? The same x coordinate right here. This is root 3 over 2. Well, this one is going to be negative root 3 over 2. And this is going to be also negative root 3 over 2. And we are talking about this value right there, this coordinate, okay? Okay, well, what's going on when you're dealing with the pi over 3's? Well, this is 1 pi over 3. And this is 2 pi over 3. 3 is just pi. That's 4 pi over 3. 4 pi over 3. And that's 5. That's 6 minus 1, 5 pi over 3. Okay? So in this case, you see it's the x that is 1/2, not the y. Therefore, it's a cosine that is 1/2. Okay? So I'm ready to write the coordinate of the point right here. I'm ready to write. Okay, let's put the points. And so now you always need to adjust the plus or minus. Okay, so right here the x is 1/2, and here it's also 1/2. Here it's, oops, I wrote 1/2, but I meant negative 1/2, of course. Here it's negative 1/2 and negative 1/2. Okay, what's the y? Well, if it ain't 1/2, it's root 3 over 2. So this you need to know. Okay, root 3 over 2. And wait, I need to adjust, sorry. So plus root 3 over 2 right here and plus root 3 over 2 right there, because you can see both of them are positive, right? Positive value right here. Oops, it again. Positive value right there. Okay, and right here they're both negative, right? Negative. Come on. What happened there? Ooh. I pushed something. Where am I? I'm right here. Ah, got it. I still lost the axis. Here we go. All right. Sorry about that. And sorry. This is negative. Oh my goodness. I shall not curse. Okay. In public. Negative root 3 over 2 right here. And negative root 3 over 2. Okay, so this is just a trick for these angles. So how do you use that? Well, let's see. What would the sine of 5 pi over 3 be? Well, hey, listen, it's a 5 pi over 3. Actually, let me see if I can go a little bit right here. Okay, here, let's play as if we didn't have the circle. Okay, and then we'll see. So let's go. Sine of 5 pi over 3. So this is what I see quickly in my head. I'm close to the x-axis, therefore the x is 1/2, so the sine is going to be plus or minus root 3 over 2. It's not, it's the x that is 1/2, right? Because I'm close to the y-axis. Did I say x? I meant y. I'm close to the y-axis, so the x is 1/2. So the sine is root 3 over 2, and I'm negative. That's it. Okay. How about the secant of 7 pi over 6? Okay, a pi over 6 is close to the x-axis, and in this case it's y that is 1/2. Y that is 1/2, and so the x is root 3 over 2, but this one obviously has to be negative. Oh, wait, that's a cosine. So flip it, that's all. Okay, negative 2 over root 3. That's a secant. Okay, you gotta be careful with that thing. So let's do a few more, just for the practice. What about the cosecant of 2 pi over 3? All right, 2 pi over 3 is the one that is close to the y-axis. If you're close to the y-axis, the x is 1/2. So the sine is going to be root 3 over 2, right? You're going to be dealing with root 3 over 2. I'm going to flip it, 2 over root 3. Let's figure out the sine. It is a plus. That's it. You see how it works? Let's do 2 more. What about the secant of 4 pi over 3? All right, 4 pi over 3. Where am I? 4 pi over 3. I'm close to the y-axis. It's right there. You need to know where the angles are, okay? It's right there. For the pi over 3, it's the x that is 1/2, right? So yeah, that's the right one. That's the x. The secant is x. Actually, it's 1 over x, so it's the reciprocal of 1/2, which is 2. And the sine, well, it's going to be negative because x is negative there. Okay, you see what I mean? It's really quick, actually. Last one. Here, let's take a 10. 10 of 7 pi over 6. So 10, of course, is a little bit more involved. Let's place 7 pi over 6. 7 pi over 6 is actually, I'm going to give you something for 10. 7 pi over 6 is right here. Okay, so the x is 1/2 and the y, and the y is 1/2 and the x is root 3 over 2, right? So it's y over x, so it's going to be the y is 1/2 and the x is root 3 over 2. Of course, you can simplify right away. If you multiply both sides by 2, that's gone, right? And you're left with, I'm going to adjust my sign after, 1 over root 3. Now, what's going on with the plus or minus? Well, the x right here is negative and the y is negative, so they're both positive. Here we go. That's 1 over root 3. Okay. So these were so it's a bit longer here. I've shown in class a way to remember the pi over 6s, the values of 10. I'm going to show you that. But before I do that, let me give you the last family of angle, you know, the one in the middle. So we went over the red, the blue. Let's go over the green. That's very, very, very simple. It's the easiest of all. Here's a unit circle. Here the x-axis, the y-axis. And so now you're just dealing with the multiple of pi over 4. So this is very simple. It's right. We call this the bisector, right? It bisects this angle right here, angle bisector, right in the middle. So that's extremely simple. For both values, sine and cosine is going to be the same. They're going to have the same magnitude, the same length. You just need to adjust the plus or minus, okay? And the length is 1 over root 2. Oops, 1 over root 2, not 1/2. It's okay if you write root 2 over 2. I'm not a fan of rationalization. You need to know how to rationalize, okay? This is very important, but it's a fallacy to believe you have to rationalize the denominator. That's what I'm not a fan of. So let's see right here what's going on. The x is positive and the y is negative. Okay, here we go. Right here, they're both negative actually, right? X and y are both negative. And right here, the x is negative, root 2, and the y is positive. Okay, that's it. What did I just give you right here? I give you the sine and cosine of all the pi over 4 angle. Here, I didn't write the angle. This is 1 pi over 4. 4 minus 1, 3. Why did I say 4 minus 1? Because 4 pi over 4 is pi. Okay, so that's 4 minus 1, 3. And this is 4 plus 1, 5. 4 pi over 4 is this one right here, right? It's pi. 4 plus 1, 5. And 8 minus 1, 7. 8 pi over 4 is 2 pi. That's it. So quickly right here, what is, for example, the secant of 7 pi over 4? Well, where is that? Oops, yeah, well, okay, fine, I did this one first. It's this one right here, right? 7, it's, no, it's not, sorry. It's not at all here. 7 is 8 minus 1. So it's this one right there. So the secant is going to be positive. So that would be 1 over root 2, but because I have to flip it for the secant, it's just root 2, okay? Right, the cosine is 1 over root 2, so you have to flip it, so it's just root 2. What is the cosecant of let's say 5 pi over 4? Okay, where's 5? Let's try not to make a mistake this time. 4 plus 1, 5. I'm right here. So cosecant is x. No, sorry. It has to do with y, right? It's 1 over y. So y is negative, so it's negative. It would be 1 over root 2 if it were the sine, but it's a cosecant, so it's negative root 2. You gotta flip it, okay? When you flip 1 over root 2, okay, it's just root 2. That's it. And that's one of the advantage of not using the notation 1 over root 2 over 2, because if you flip that 1 over root 2 over 2, you're gonna find 2 over root 2. And this you cannot leave like that, okay? I'm not a fan of rationalization, but in this case you have to rationalize because it is simpler, okay? And that's just root 2, which is what I just found right there, okay? Okay, I'm gonna stop the first, or maybe I should go further and show you how to use that. Of course, right here the 10 value are very simple, right? The 10 value for pi over 4 are extremely simple. If you are on this axis, either the pi over 4 or the 4 plus 1, 5 pi over 4, then the 10 value is plus 1, right? Why? Because both sine and cosine are the same, and they have the same sign, sign, okay? Here they're both positive, and here they're both negative, so the negative sign will cancel. If you are on this axis, right? So this is 3 pi over 4, and this is 7 pi over 4. Then here, the tan value is -1, because again you have the same absolute value for sine and cosine, but they both have different sign. Here sine is positive, cosine is negative, and here cosine is positive and sine is negative. Okay, so they both have different signs, so it's -1. Okay, I'll stop the video right here. In the next video I'm going to show you what you're going to have on the quiz.